Hey guys, welcome to my YouTube channel, and we're going to pretty much work on reinforced concrete design. How do we read structural drawing? Sometimes it's kind of hectic. It seems as if we are studying grades when we see structural drawings. They're not as easy as the architectural drawings one. And I'm also going to give you a manual, a calculation sketch value which I've done to come up with the bars which we're going to use in our calculation today. So I'm going to fill you in immediately. So this is actually the manual. It's actually titled Design of Reinforced Concrete. You're going to see it, go through it, and appreciate the computations. They are easy to follow. And I'm also going to attach an image which illustrates the sizes and the area of steel provided. Again, it's a supporting document to this manual. I've sketched it, so and where you find an error, feel free to comment. So go through it, and I'm going to jump straight to summary. So after that computation, I got these parts which are going to use in our illustration today. So I'm going to I used what's happening. So I used Chica to manually sketch those bars. And from the manual, if you go through the manual, use ultimate limit step method to design BS8110 part 1 1997. So this is a sample design of analysis wrap. And let me start with the labeling. There are four parts. We have the bottom one, bottom two, top one, and top two. And let me begin with bottom one. So as you can see, it spans from this point to this point, and it's actually parallel to the shutter span. Any bar you see parallel to the shutter span, and it's at the same time spanning maybe from one point of the beam to the other point of it. Just immediately register at the back of the mind we are having a bottom one, and it's labeling is so simple. We have what we call the bar size, which is 8mm bar size. Why defining the type of bar? For instance, in our case here, we have what we call square twisted bars. Since in my computations I used 460 newton per square millimeters, but this I think it was phased out. We have what we call T bars, deformed bars. So you might want to change this, but you have to change your computations. The second portion is what we call the bar mark. Bar mark symbolizes bars of the same diameter and of the same size and of the same positions. In position I mean bottom one, another bottom one with the same size, with the same length. It's going to be labeled as bar mark 1, and we have 250 representing the spacing, that is 250 millimeters center to center. Bottom one, the position of the bars. And again, you find this bar has some kind of weird thing going on here, where I'm pointing with my cursor. This is what we call planking, and it's basically done as 25% of the shutter span. So that is 25% of 4.2 meters. So from this edge to this point, we have what we call a 25% length of the planking. So that's how we come up with the bottom one. For the bottom two, it's the same, but if you look closely here, I've added something 18. 18 now represents the number of bars. There are 18 square twisted bars, 8mm in diameter, bar mark 250 center to center, and now they are bottom two. Bottom two meaning that they are spanning parallel to the longer span being 4.5 meters, and as you can see, it's parallel to the 4.5 meters edge. And the spanning, as you can see, this is the spanning which is shown by this dimension line from this point to this point. And how to compute the number of bars, we take now the spanning, which is 4.2 meters, that is from this position to this position, less this gap here, which I'm calling it the cover, taking it as 25 millimeters on this end and again on this end, then divided by the spacing, which in our case for bottom two is 250 millimeters. center to center plus 1, get 17.6, approximately 18 bars. Then the bar mark 02, since it's of different length and in different position, which is bottom 2 and 250 millimeters center to center. Then for the top 1 bars, so the top 1 bars are kind of weird, because when we have them on the continuous edges is illustrated. Continuous and discontinuous edges is illustrated in my manual. So if you have them on the continuous edges, they kind of slice those beams which they pass through. For instance, this is a bar which is cutting through this beam, and the point where it ends is 25% to the edge of this beam, and again 25% to the edge of this beam. You leave that it's a clearance actually. And we have these bars which are acting as top 1 being shown there. And as you can see again, the same labeling principle, but now we have them in T1, which is top 1. On this other end, our top 1 is actually represented by, again, the same way, slicing this beam. Just realize and understand that this rise, actually they are what is rising, where you have a continuous edge. We have these bars acting as top 1, slicing the beams, 25% clearance on this end, 25 clearance on this end, on this other end. On these discontinuous edges, our top 1 becomes this clamped end. As you remember, we clamped again 25%. So that now becomes our top 1 bar, and the same goes to this other end. Our top 2 bars, they kind of span. As you can see, this is a top 2 bar spanning from this end to this end. Again, take 25% of the shorter span. On the other end, again 25% of the shorter span, 25% of the shorter span on this other end, and 25% of the shorter span on this other end. And as you can see, we have some slight differences between the labeling of this top 2 and this top 2. They're actually the same. What we have done, we have shortened it. Since this bar is of the same size as this one and of the same diameter, so what we do, we label the number of bars and the bar mark. It's simple as that. If we have the same bar mark, then you don't need to repeat the Y and the spacings and the position. It's by indicating 7 and 6 will mean 7 bars and bar mark 06. So that's it, guys, on how to read the structural drawing, the snippet on Slabs. Many more are to come, so if you sure want to see more, you can do something by hitting the like button and the subscribe button. Let me hear your comments. Maybe I'm not an engineer, but there's some areas we need to improve, some areas which you see were not well covered, or there were some errors. I really would appreciate your comments. So until next time, see you guys.